Hey guys, we're going to start today with some awesome jokes again. First, what's a teacher's favorite candy? Chalk olet. What kind of food do math teachers eat? Square meals. And why did the amoeba flunk the math test? Because it multiplied by dividing. Alrighty guys, let's go ahead and get started with today's notes. We are talking about notes number 7, writing equations for tables. So this should be a quick set of notes. And I bet you guys know how to do this if I didn't even make a video for you. So what we're going to be doing is we're going to find the slope and the y-intercept for each table, and then we're going to write an equation. We're going to write our equation in slope-intercept form. So a reminder, slope-to-intercept form is y equals mx plus b. And so let's go ahead and get started with number 1. Number 1, what I'm going to do is I'm going to look for the change along these tables. So starting with my x, each one of these increased by 1. My y values, these each increase by 2. Now remember, when we are talking about slope, we talk about the change of y over the change of x. So I want to make sure I'm doing 2 over 1. Okay, and if I wanted to, I could simplify that to 2 when I rewrite this as an equation, which actually we will. And then my y-intercept, my b, okay, this is given to us in the table. So when x is 0, my y-coordinate is also 0. So when I write the equation for this table, I can go ahead and write it as y equals 2x. I can add the plus 0 if I want to, but I don't need to. So this is good enough. If you wrote in plus 0, I won't take off. So that's fine. Now let's go ahead and move across to number 2. Number 2 is I'm taking a look at my x coordinates. Those all increase by 1. Then if I take a look at my y values, these also all increase by 1. So in this case, my slope, my average rate of change, don't forget that those are interchangeable. It is 1 over 1. My b, okay, so again, this is when x is 0, what's the y-intercept? It's given to us again, 3.5. Now let's take all this information and write it in an equation. So y equals 1 over 1 is just 1, and I can write it as just x. X plus 3.5, or 3.5. All right, let's go ahead and talk about number 3. Number 3, again, my change in my x values, they all increase by 1. Change in my y values, these all increase by 2. So I can go ahead and state that my slope, remember, change of y, so that's 2 over 1. Now what is missing is when my x is 0, what is my y? So this time, that's not given to us. But I can just kind of like put that in at the end of my table. I can put it there, or I could put it over here. I don't know why I'm writing 0 in. Sorry about that. I meant to just write 0 on the other end. So basically, I know for my x coordinates, I have just one movement of going backwards one time, minus 1. Okay, and so if I'm doing just one time, minus 1, down here, I'm going to go minus 2 to get that y-intercept. And so 1 minus 2 is negative 1. Okay, so it doesn't matter where you put it, on the front of the table, the back of the table. I guess it just depends on where you have room. So my y-intercept is 1. And so the equation for this table, we'll go ahead and write it again as simplified as possible. So y equals 2x minus 1. It's table 3. Okay, now table 4. Table 4, x values increase by 1, y values, these all seem to decrease by 3 this time. So I can go ahead and write down my slope is negative 3 over 1. Remember, change of y over my change of x. I need to figure out what b is, because again, 0 is not there. So this time, I have to go back 2 to get to 0. So that means I'm going to go I guess, two movements to get there. So I am going to subtract by, instead of subtracting by 1, here, let's move this out of the way. Put that right over here. I'm subtracting by 2 to get the two movements. And then down here for my change of y, again, I have to do two movements. So instead of subtracting by just -3, I am subtracting by -6. So 11, and I kind of decrease by -6. That gives me -5. Okay? So if you're kind of lost, let's think about it this way. So I'm going to erase that. That is the right answer. So, but again, just kind of in case I lost you. Let's figure out when x is 1, what's my y? So -11 minus, subtract 3, it is -8. Okay? Then 0, again, I'm taking that and I am kind of, I guess I don't want to say I'm subtracting -3, I'm adding 3. I have -5. So again, I could always do it on this end of the table as well if I wanted to. However, to make it fit, to make it make sense. Okay? And then the last thing we're going to do is write the equation. The equation is -3x minus 5. And then the last table, number 5. Number 5, I see all of my x values. They are increasing by 5. All of my y values are increasing by 2. Now, again, I can extend, and so I guess, hold on, I'm getting ahead of myself. My slope here is 2/5. Again, the change of y over the change of x. I need to find out what b is. And I could, keep increasing 5. That's one way to do it. And that's fine if that's the way you want to do it. But if you're dealing with large numbers or larger than this, I want to go back and I want to remind you of the equation that we did on our last notes. The equation is slope-intercept form. So we know slope is 2/5. Okay, we're solving for b. And we have ordered pairs that we can substitute in for x and y. And so I'm just going to go ahead and take this one right here that I see, -20, -2. So I'm going to put -20 in for, -2 in for y, and -20 in for x. And then I just solve. Okay, so that's -4, gives me -8. So 2/5 of -20 is -8. I'm going to add 8 to both sides. And so I have b is equal to +6. Okay? And now I can write my equation. My equation, squeeze that in right here, is going to be +2/5 x plus 6. All right. So again, either way works. You can continue the pattern on the table. Sometimes you might have to use a separate sheet of paper, or you can do some quick algebra, just like I did right here. Okay. The last problem right here is just a little bit of a story problem. Hopefully nothing too challenging, but I found this on an old end of course exam, and I was like, oh, we'll go ahead and try it. Ryan works for a delivery service. The function f of n is used to calculate his daily pay in dollars on a day when he makes n amount of deliveries. So the function is f of n is equal to 7n plus 96. We're going to use the function to complete the table. So what this is doing, I could see that this is testing your function notation. So we're going to remember that my table is x and y, or in this case, n, f of n. Okay? There's two ways you can do this. You can go ahead and use your graphing calculator. Look at the table and try and come up with the values. The other way that you can do this is algebra, and actually sometimes algebra might be quicker, because if you're getting very large numbers in your graphing calculator, that might take a little bit longer. So very quickly, if we had to prove with algebra by showing work, okay, to solve for our first one, 0 deliveries, we would be putting 0 in for n and solving for f of n. So in this case, we know that 7 times 0 is 0, so f of n is 96. Okay, that one's nice and easy. The next one, again, we're going to go ahead and put 5 in for n and solve for f of n. So 7 times 5 plus 96. 7 times 5 is 35. 35 plus 96. We get 131. And then the last one is, this time, f of n is given to us, 145. And then we are solving for n. And so we'll go ahead and start by subtracting 96 from both sides. So 145 minus 96 is 49, equal to 7n. Divide both sides by 7. N is equal to 7. So we have 7 right there. Okay. So nice little review. And hey, that's it for these notes. See you guys next time.